The quiz for today was simply to make a couple of tables and plot a couple of graphs. And, just put this here so I'm not distracted by all of that stuff. And try not to knock things over, and here we go. Okay, so right there are the problems. There are two linear functions. We'll see what linear functions are. It's two y equals y equals. Okay, so make table, plot each line by first making a table. Okay, so take y equals -2x plus 6. Now, I specified what x values to use for this function. I didn't specify for this, so you'd be welcome to use whatever x values you like. But since everybody used these x values, they're fine. I'll do the same. And there's something to be learned from doing that about scaling the graph and so forth. Okay, so we have x, we have y. X is -14. Y is, well, I'll go ahead and do the calculation. -2 times -14 plus 6 equals 34. Y equals -7. We have -2 times -7 plus 6. And 2 times 7 is 14. The negatives give you a positive. We add 16, we get 20. X is 0. Well, that one's easy because 2 times 0 is 0, and we get, I'll write it anyway, -2 times 0 plus 6. And we get 6. And I think people evaluated these mostly correctly. I didn't look at the details. More concerned with the procedure. Then we have -2 times 7 plus 6. It's -14 plus 6, which is -8. And then -2 times 14 plus 6. That would be -28, and 6 equals -22. Now, assuming I did my arithmetic correctly, I say this is a linear function. That means these points should all lie on the same straight line. Now, depending on how well you scale your graph and how well you sketch your graph, it might look more like a straight line or less. But let's just see what we might get here. Okay, so first thing you have to do is make a graph. And everybody did a really nice job of saying that this graph has to go all the way out to 34 and all the way over to -22. Okay. Now, a couple of ways you can scale this. It would be okay to say, okay, I'm going to use 10, 20, 30, and 40. Instead of drawing 34 lines this way and 22 lines this way, which would take you all night. Wouldn't take you that long, it would take you a while. So I'm going to put 40 here. I'm going to write x equals 40. So here's a vertical line, and every point on this line has an x coordinate of 40, doesn't it? Because x coordinate of this point, we go down, we get 40. X coordinate of this point, we go up, we get 40. So this dotted line consists of all the points where x equals 40, and that's worth noting. Okay, it's worth understanding. Well, then I can cut this interval in half. I get x equals 20. Then I can cut this interval in half, and there's x equals 10. I'll label that up here. And I can cut this interval in half. And halfway from 20 to 40, everybody should understand is 30. Okay, then I've got to go to -22. Well, I see how big 20 is. So I go that far on the other side, and I'm going to say here's -20. And then I could put x equals -10 here. So now I've got a reasonably well-scaled graph. Now my intervals, this and this and this and this ought to be the same width. Okay. You know, I think this one a little fatter right here than it is here. So we're not going to get a perfect graph. We can't expect to get a perfect graph if we're drawing it by hand. Still, it's important to be able to a graph by hand without destroying the surroundings here. Okay. So it's a skill I want you to work on. And everybody actually did reasonably well with this. Okay. Since your homework was to do this using a grid that Open Math already gave you, and instead of plotting points by hand and thinking the way you would think in plotting points by hand, using the computer to locate the points, that's not bad, but you learn a lot by sketching your own graph. Hey, don't be too meticulous with it, because you can always go into Excel or go into something else, all kinds of options on your calculator or your phone, and sketch a more accurate graph. Still, in this class, you're going to have to hand sketch it. And again, that causes you to think and relate to the graph in a more physical way. And I think you learn more. And I think there's evidence that you do. Maybe I'm cherry picking the evidence, but I think it's going to turn out that way. Okay. So anyhow, here we have it. Then, you know, I did something really ignorant there. I labeled X's out to 40, right? I don't need X values out to 40. I only need X values at 14. It's the Y values that should go to 40 and -20. Okay. So you'll see. And I was honest. I mean, I really made that mistake. So I'm going to change the numbers on my X's here. I don't want numbers like 40 and 20 and 30 and 10. You know what I'm going to use? I'm going to use 16 out here. Why am I using 16? Because it's easy to cut 16 in half. If I cut 16 in half, I get 8. And if I cut 8 in half, I get 4. And halfway between 8 and 16, you can figure out easily, is 12. So over here, I'm going to have X equals -4. And X equals -8. And then I've got to go to -14. So I'm going to draw 2 more lines, pretty much equally spaced. -16 will go here. And -12 will go here. Understand what I just did? I scratched out the numbers that I already had and used these numbers. Now, my 16 over here is a little too big. This line should have been a little further this way, and this one's a little fat. But that's okay. You're not going to make a perfect graph. Okay. Now, we need Y equals 40. Then we're going to have Y equals 20. Y equals 30. And Y equals 10. Then we got to go down 20 units this way, which will put us about here. Then again, I want you to be able to do this by hand, using a little common sense instead of having a grid somebody puts on a computer for you, or somebody hands you a piece of graph paper, okay? Not that there's anything wrong with graph paper or what the computer does, but you learn more. You get a better sense of the reality if you do as much by hand as possible, at least when you're learning, okay? And again, that's what you're going to have to do in tests. Now we can plot our points. X is negative 14, Y is 34. Where is negative 14? Now let me use a different color. Here's negative 12, here's negative 16. So negative 14 is like here. And Y equals 34. Well, let's label this. X equals negative 14 on this line. Y equals 34. Where's 34? It's between 30 and 40. Halfway between 30 and 40 is 35. So it's a little bit closer to 30 than it is to 40. So I'm going to draw it about here. This would be the line Y equals 34. And where this horizontal line for Y equals 34 crosses this vertical line for X equals negative 14, there's our point. Now, does all that make sense? Okay. Then we have negative 720. Where's negative 7? Well, here's negative 8, and here's negative 4. It's between negative 4 and negative 8, and closer to negative 8. We could say, well, negative 6 is halfway here, and negative 7 is halfway between there and negative 14 or negative 8. But I'll just say, okay, here's X equals negative 7. That'll be this line. And we want Y to equal 20. Well, that's convenient because we already have a line for Y equals 20. We don't have to draw another one. Then we have the point where X is 0 and Y is 6. Okay, well, X equals 0, of course, is the Y-axis. We could label that X equals 0, and we could label the Y-axis Y equals 0. So we want the point 0, 6. Now, where's Y equals 6? Well, it's between 0 and 10, and a little closer to 10. Here's the line Y equals 6. We're going to put a mark on that. Then, when Y equals 7, X equals negative 8. Okay? Well, Y equals 7 is going to be about here. X equals 7, sorry. X equals 7 is about here. And Y equals negative 8. Down here, pretty close to Y equals negative 10. I might have it a little high. Here's the line Y equals negative 8. And here's the next point on the graph. Then finally, when X is 14, Y is negative 22. So 14 is halfway between 12 and 16. So here's X equals 14. And here's Y equals negative 22, just a little below the Y equals 20 line. Now, there's a lot of stuff on that graph, and it was done fairly carefully. I didn't get my scale exactly right. It's a little too wide on the left. But you see, if I put this, I'll put this meter stick just below the X's. You see that those X's line up pretty doggone well. Right? So we have a very nearly straight line. And then if I attempt to draw that line, wish me luck. Yeah, I did a pretty good job. Okay. The secret to drawing a good line. You start here, and then you look at the line, the point that you're aiming at. Okay. If you're looking at the point that you're aiming at, you're probably going to come pretty close to it. If you try to look here, here, and here, and here, it's not going to be so good. Okay. And we don't, when we're sketching the graph of some equation like this, we don't draw a jagged line from point to point. We try to draw the smoothest curve we can. Now, nothing's smoother than a straight line. Okay. So kind of keep that in mind. Okay, now I'm going to do this one a little more quickly. But think about what I was telling you here and then watch what I do here. Okay. So let's see. X equals -14. And y is 3/7 x minus 4. Now, if you have trouble with these fractions, you probably should review the fractions. Okay, if you're still having trouble with it, I can give you more reference. Open Math doesn't have that much on fractions because Open Math is aimed mostly at college level courses. Okay. But Khan Academy is a good source. So if you're having trouble with the fractions, let me know. But that's like 3/7 times -14/1. Now I'm going to do that calculation up here where I've got a little bit of room. Okay, first place, -14, I'll write as -14/1, which removes any confusion in what you do when you multiply a fraction by a whole number. Okay. And you multiply the numerators and you multiply the denominators. And it's yeah. So it's 21/7. Let me just do all the steps. -3 times -14, and that isn't -21. We looked at some numbers and something just clicked and it was the wrong thing. -3 times -14 is 42. 42/7 is 6. And we end up with 2. All right. That's how the calculation is done when x equals -14. And the other calculations are done in a very similar manner. Okay. So we get 2. When x equals -7, we get 1. And x equals, no, we don't. Yes, we do. Okay. No, we don't. We get 2. Okay. -7, we're going to get do something wrong. 3/7 of 14 is 6. Okay. 3/7 of 7 would be 3. 3/7 of -7 would be -3. And I made a mistake here when I wrote the coefficient as -3/7. So this wasn't quite right. It's 3/7 times 14, which is negative 42 over 7, which is negative 6 minus 4, which is then negative 10. Okay, made a clerical error. I put a negative in front of that 3/7, it shouldn't have been there. And then when I got over here, things just weren't working. So I knew something was wrong. So it's this. Again, if you write down the right sign here, it's exactly the same steps. The only difference is you're not going to have two negatives. You're going to get a negative 42. And so you can follow that. So that's negative 10. Okay. And then 2/7 to negative 14. Is negative 28. Yeah, okay, that's going to be negative 8. That can't be right. If you go back to 5th grade, I guess I'm having trouble making a click in my head. But 7 will go into 14 negative 2 times yet. Okay. 3/7 to negative 14 to negative 6. That's pretty clear. I should get negative 6, and I do. Negative 6 minus 4. I'm going to pause this thing and see why I'm stuck in a loop here. You're not getting the right numbers. The numbers just weren't clicking in my head because I was kind of hung up on something I did over there and kept getting it. But anyhow, we do get negative 7, and now that's right, because then 0 is just going to give us negative 4 because x is 0. Negative 4 is all we have. And let's kind of write that out. 3/7 times 0 minus 4 is 0 minus 4, which is negative 4. Then if we evaluate the rest, we're going to get negative 1 and 2. And just check that out. If this was 14 instead of negative 14, we'd have a plus 42 over 7 minus 4, which gave us 2 before. Okay, so there we have the numbers for our table. Now, why did I tell you to use negative 14, negative 7, 0, 7, and 14? Because 7, our denominator here, divides into each one of these numbers. These are all multiples of 7. So I made a choice here that I didn't think you were necessarily going to make. Okay, I made a choice here to use multiples of 7 so that the 7 would divide and give us an easy calculation and give us numbers that are easy to locate on a set of coordinate axes. Okay, well, let's see what the graph of this thing looks like. Okay, just a little space here. Now we want to draw a graph of this thing. So here we go. Here's a graph. We set of coordinate axes. Our x values go from negative 14 to 14. Well, we're just going to say, okay, here's x equals negative 14. And then I go this distance from the other side of the axis. That's got to be where x equals 14. And then halfway from here to here, halfway from negative 14 to 0 is negative 7. And halfway from -7 to 14 is 7, and now I've got all my x values. My y values go from -10 up to 2. Okay? So I can go ahead and sketch a line here for y equals -10. And then if I divide that in half, I get y equals -5. Halfway back to y equals 0. And then y equals 5 will go above the x-axis as far as y equals -5 goes below. Make sense? Then I plot my points. And that's very straightforward. Okay. -14, -10. Well, right there we have it. X is -14, y is -10. When x equals -7, we get y equals -7. So let's see. Here's x equals -7, y equals -7. Let me use the blue chalk. Y equals -7 will be somewhat closer to y equals -5. 7's between 5 and 10, closer to 5, right? Well, -7 is between -5 and -10, closer to -5. And we're going to get a point here. And then we're going to get x equals 0, we get y equals -4. So, well, that's going to be right close to -5. There's y equals -4. And there's, whoops, x equals 0. You know, that wasn't going to work out well. That wasn't going to be on a straight line with these, and I know this has to be a straight line. Okay, then from y's 7, x equals -1. Well, -1 will be up here closer to 0 than -5. That gives a point about here. Then y equals 2. Say y equals 2 goes about here. And there we have it. So let's see how close we came to a straight line. Okay, well, you know, kind of, if I draw a line from this point to this point's right on it. This point's a little high and this point's a little high. But you're going to get a little bit of that, even if you're very, very careful. Unless you've got a very detailed piece of graph paper or something like that. But we're going to come close enough to the correct line. And there we have it. So we see all these points lie reasonably close to a straight line. And if it was done with complete accuracy, they'd lie right on a straight line. Now, open math, generally when you plot things, use a great big old dot. Okay? Does the graph really go through the center of all those dots? Well, yeah, probably if you've done it right. But it can be hard to see where the center of a big fat dot is. There are a lot of optical illusions that are involved when you're looking at all the shapes on the graph. So it's very conceivable you won't be completely accurate, even if you use open math plotting points on a grid. Now there are, you know, there's Excel. Have y'all seen Excel? So yeah, you can use Excel to do these graphs, okay? And you get a much better looking graph, although Excel tends to make pretty fat points if you're not careful, okay? And that affects your accuracy to an extent. Okay, now I want to talk about let me check the order of topics here. Because we're going to follow open math topics, although I kind of designed these assignments. Okay. Here's a question. I want you to write down a number for me and circle it so I can find it quickly. There aren't that many people here today, so I have time to search a little bit, but still get in the habit of making your answers easy to see. Okay, so my question is, here's a complete statement of the question I want to pose. What are the coordinates of the points where the graph crosses each coordinate axis? Okay, now what do I mean by the coordinate axis? I mean the x-axis or the y-axis, right? Can you write down the coordinates of the points? The graph crosses the y-axis and it crosses the x-axis, so it'll be 2 points. Could you write down the coordinates of those 2 points for me? As best you can estimate them from the graph. Okay, now people needed a little bit of help with this. They didn't make a copy of this graph. So here's how I would recommend you label the graph you just made. I ask everybody just draw a line that looks kind of like this, graph that looks kind of like this with the x-axis and the y-axis, right? So everybody, here's something that kind of looks like this. Okay. That's good. Then I said, okay, now can you circle the points that the graph crosses each coordinate axis? And yeah, everybody did. Everybody circled this point and these points. Okay. Now, on this graph, that would be this point and this point. Now, we've got the scale, x is 14 here, x is negative 14 here, right? And y is negative 10 here and 5 here, okay? Now, can you estimate, just looking at this graph, what the coordinates of this point would be and what the coordinates of this point would be? Okay, that took a little while to get oriented with the question, but now everybody wrote down good coordinates, okay? And from where you're sitting, we had estimates of, well, everybody knew that was 0 and negative 4, right? Because of course, that's on our table. Okay, so we know that that coincides just with this point that we made at 0 and negative 4. This point, well, let's just draw. And I had 2 estimates here. I had 0.7 and 0.8. Okay. So let's just see if I draw the vertical line between these points. Well, actually 0.7 and 0.8 we're quite right. If you're thinking that this is x equals 5 here, and this was 10, this is 5 and 10, then that's about 7, right? If this is 7 and this is 14, right? Okay, so we're between 7 and 14. Okay. So we've got 7 units here. We're somewhat less than halfway. So I'm going to say Looks to me like it's about 3 units here and 4 units here, but it's not quite 3, maybe 2.5. But just for the sake of a whole number estimate, I'm going to say this is probably about, did I say 0.4? Anyhow, this is about 10.0. Okay. I think everybody had the right idea. But I didn't ask you to write the x equals, and if you were thinking 5 and 10, the estimates that you made, 7 and 8, were reasonable, okay? If this is 7 and this is 10, 9 or 10 would be the better estimate here, okay? I'd go 9.5 or something like that. We'll just use 10. Okay, well, that's not going to be completely accurate. Now let's test that, okay? I can't test that unless I know where my chalk is, okay? Got all kinds of black chalk in this room. There we go. Okay. No, keeps running off. Okay, so now what we're saying is okay, the point where the graph meets the x-axis is called the x-intercept. Okay, so we estimate the x-intercept to be 10.0. Okay, now we ask the question: does 10.0 satisfy y equals 3/7 x minus 4? Okay, well, x equals 10 when y equals 0, then if y is 0, well, we're going to put 0 in for y. And if x is 10, we're going to put 10 in for x. Okay. Now, 3/7 of 10 is about 4.8. Okay. Let me do that again because my brain just rested. It's actually about 4.3. I don't know what I'm thinking. No, we're dividing 7 into 30, not 21. Okay. Like I say, 4.3. I guess that is what I said. Okay, so actually, that was a pretty good estimate. We didn't exactly get 0, but we got something very close. Okay. So this tells me that I had a pretty good estimate of the x-intercept. Even though I thought it might be halfway between 9 and 10, I think it's closer, clearly closer to 10. It's a hand sketch graph. I can't expect complete accuracy. Now, we're going to ask the question we're going to find. The x-intercept. Now, this is really important. It's something I never can convince students to think of when it needs to be thought of. So see if you can be the first group that ever really got this on the first try. Most groups don't even get it on the 30th try. Can you read that? The graph crosses the x-axis when y equals 0. Is that obvious? Well, the x-axis is where y equals 0, isn't it? The x-axis is the line y equals 0. So you want to find x when y equals 0. How do we do that? Well, we write y equals 3/7 x minus 4. So if y equals 0, we get the equation 0 equals 3/7 x minus 4. So write down that equation and see if you can solve it. I'm not going to give you very much time because we're running short on time. Give you just about a minute to see what you do with it. If an equation has denominators, the safest thing to do is usually to multiply by a common denominator. Multiply by the common denominator, meaning multiply both sides by a common denominator. That gives you 7 times 0 equals 7 times 3/7 x minus 4, which gives you 0 equals 3x minus 28. Can you solve that? I think everybody has done pretty well with linear equations. Okay, you might need to review it because it needs to be something you can do pretty quickly. So anyhow, we get we add 28 on both sides. I don't have room to do that, but again, this is an equation you should solve in detail. Then we divide both sides by 3, 28 over 3, which equals 9.33, and then the 3's just keep repeating. Okay. So actually, I'm back to thinking that, okay, yeah, actually 9 would have been better than 10. That was pretty close, so I thought 10 was probably pretty much all right. But 9 turns out to be a little closer. But it's actually 9 1/3. Okay. Okay. And I think I want to actually write that 9 1/3. Just 1/3 makes sense. Here's 9 and here's 10, and 1/3 is twice as close to 9 as it is to 10. Okay, well, your homework is on intercepts. Now, I said that the x-intercept occurs when y equals 0. Similarly, the y-intercept occurs when x equals 0. So this red thing here, keep that right in front of your mind. Don't do things by habit. Think that through, because that's what people keep missing throughout a pre-calculus course. They can't find intercepts because they don't know what the x-intercept occurs when y equals 0, and the y-intercept occurs when x equals 0. They keep missing that step and get hung up on something really simple. Okay? So try to lock that in.